students, as we have studied in the last class multiplication of polynomial, I hope that content is clear with you all. So today we are going to study division of polynomial. Division of monomial by monomial. 10x raised to 7 divided by 2x raised to 4. Solution: 10x raised to 7 divided by 2x raised to 4. So how do we solve? Which is equals to 10x raised to 7 divided by 2x raised to 4. 2 ones are 2 5s are 10. So 5 x raised to 7 divided by x raised to 4. So to solve this, we are going to use the second law of exponent. As in division, we are going to subtract the powers of exponent, as the law says x raised to a divided by x raised to b equals to x raised to a minus b. So we are going to subtract the powers of the exponent. So x raised to 7 minus this term, that is 4, which is equals to x raised to 3. So the answer comes to be 5x raised to 3. Division of polynomial by monomial. The first question, 64 y raised to 4 plus 8 y cube upon 4y cube. Solution: 64 y raised to 4 upon 4y cube equals to 4 ones are 4, 16 are 64. Now again y raised to 4 upon y cube. So again here we are going to use the second law of exponent. As in division, we are going to subtract the powers of the exponent. So y raised to 4 minus 3, which is equals to y. So the answer comes to be 16y. Now the second part, that is 8y cube upon 4y cube. So 4 ones are 4 2s are 8, y cube get cancelled. So the answer is 2. So now we are going to arrange the answer. So 64y raised to 4 plus 8y cube upon 4y cube, which is equals to the first part answer I got 16y. The middle sign is plus, so plus, and the second part answer I got 2. So the whole answer, that is 16y plus 2. Simplify m raised to 6 upon m cube. So how do we solve m raised to 6 upon m cube? Now again in division, we are going to subtract the powers of the exponent by using the second law of exponent, as it says x raised to a divided by x raised to b equals to x raised to a minus b. So m raised to we are going to subtract the powers of the exponent. So 6 minus 3, which comes to be 3. So the answer comes to be m cube. The second sum, 8x raised to 9 y raised to 5 upon 2 x square y cube. 2 ones are 2 4s are 8. So 4. Now again we are going to use the second law of exponent, as x raised to a divided by x raised to b equals to x raised to a minus b. So x raised to 9 minus 2, y raised to 5 minus 3. So when we subtract this, we get answer x raised to 7 y square. So the answer comes to be 4x raised to 7 y square. Simplify the first question, 7a minus 7b upon 7. Now we are going to split and solve this sum. So 7b upon 7. So 7 gets cancelled. We are remained with a. So the answer comes to be a. The second split, that is 7b upon 7. So 7b upon 7, 7 gets cancelled. We are remained with b. So answer comes to be b. So this question, 7a minus 7b upon 7, the answer comes to be the first part a, middle sign is minus, so minus. The second answer, that is b. So a minus b is the required answer. The second sum, minus 14 x raised to 12 y plus 8 x raised to 5 z upon 2x square. So again we will split and solve the sums. So 2x square goes under this term and this term. So the first term, that is minus 14 x raised to 12 y upon 2x square. So 2 ones are 2, 7s are 14. So minus 7, as it is minus, so minus. Now we are going to solve this part, that is x raised to 12 y upon x square. So by using the second law of exponent, as it says x raised to a divided by x raised to b equals to x raised to a minus b. In division, we are going to subtract the powers of the exponent. So x raised to 12 minus 2 y, which comes to be 12 minus 2, that is 10. So x raised to 10 y. So the final answer, that is minus 7 x raised to 10 y. The second part, 8 x raised to 5 z upon 2x square, which equals to 2 1s are 2 4s are 8. So 4 x raised to 5 minus 2 z, which comes to be 4 x cube z. Again, we have used here the second of exponent. So the final answer comes to be minus 14x raised to 12y plus 8x raised to 5z upon 2x square equals to minus 7x raised to 10y. The middle sign is plus 4x cube z. The next sum, 100 x raised to 5 plus 16 k raised to 4 upon 4 k cube. So again we are going to split and solve this sum. So 100 k raised to 5 upon 4 k cube. So 4 ones are 4, 25 is 100. So 25 k raised to 5 minus 3. As in division, we are going to subtract the powers of the exponent. So by using the second of exponent, x raised to a divided by x raised to b equals to x raised to a minus b. So I have just subtracted the powers of the exponent, that is 5 minus 3, which comes to be 2. So 25k square. The second split, that is 16 k raised to 4 upon 4 k cube. So 16 k raised to 4 upon 4 k cube equals to 4 ones are 4, 4s are 16, 4 k raised to 4 minus 3, which is k. Again here we have used the second of exponent, as it says x raised to a divided by x raised to b equals to x raised to a minus b. So answer comes to be 4k. So 100 k raised to 5 plus 16 k raised to 4 upon 4k cube equals to 25 k square plus 4k. So students, now we will learn division of polynomial by polynomial.
Plus 5x minus 3 divided by x square minus 2. As the polynomial is not in the perfect decreasing order of the degree, we rearrange the terms. Like x cube will come first, then x square and so on. So it will become x cube minus 3x square plus 5x minus 3 divided by x square minus 2. Now let us start the long division process. First, to get the first term of the quotient, divide the highest degree term of the dividend by the highest degree term of divisor. So we do x cube divided by x square. So we get x. We write x as the quotient above the line. Now we multiply x square minus 2 by the quotient x. So we get x cube minus 2x. We write it below the dividend, but matching its degree to the each term. That is, we write x cube below x cube and minus 2x below 5x. Now we subtract x cube minus x cube equal to 0, plus 5x plus 2x is equal to 7x. So 5x plus 2x equal to 7x, minus 3x square and minus 3 from the dividend comes down. So the remaining dividend is minus 3x square plus 7x minus 3. Now again we repeat the process. We divide the highest degree of the remaining dividend by the highest degree of the divisor to get the quotient. So minus 3x square divided by x square gives minus 3. We write it as the quotient above the line, and then we multiply by the divisor x square minus 2 by the quotient we got, which is minus 3. We get minus 3x square plus 6, which we write it below the remaining dividend and matching its degree with each of the terms. So we will get minus 3x square plus 6 below it. Now we subtract minus 3x square plus 3x square, so it becomes 0. minus 3 minus 6 will become minus 9, and 7x comes down. So we get 7x minus 9 as the remaining dividend. Degree of 7x minus 9 is 1, whereas the degree of the divisor is 2, x square. Here the remainder is 7x minus 9. So we cannot divide 7x minus 9 by x square minus 2. That is, the degree of the remainder is lesser than the degree of the divisor. So division stops here. So x minus 3 is the quotient and 7x minus 9 is the remainder. So the division steps of a cubic polynomial are same as what we learned for a quadratic polynomial. So we can say when we divide a polynomial px by another polynomial gx and we get qx as the quotient and rx as the remainder, then px is equal to gx into qx plus rx. That is, dividend is equal to divisor into quotient plus remainder. Let's verify it in our example. X cube minus 3x square plus 5x minus 3 was the dividend px. X square minus 2 was the divisor gx. X minus 3 was the quotient we got, and 7x minus 9 was the remainder rx we got. Now let us put it in the formula. Px equal to gx into qx plus rx. Let us find the value of right hand side. It will become x square minus 2, which is the divisor, into x minus 3, which is the quotient, plus 7x minus 9, which is the remainder. Let us solve the first term, which is the product of two polynomials. We would multiply x minus 3 with every term of x square minus 2. So we will get x cube minus 3x square minus 2x plus 6 plus 7x minus 9. This simplifies to x cube minus 3x square plus 5x minus 3. Look, this is equal to our original dividend. So px equal to gx into qx plus rx holds true. So we can conclude, if px and gx are two polynomials and gx is not equal to 0, then we can find polynomials qx and rx such that px is equal to gx into qx plus rx. Here rx can be 0 or the degree of rx will be less than degree of gx. That is the main condition for the end of division process. And this is known as division algorithm for polynomial. That's all.
The content. So there is a small assignment based on it. Please try to solve it. Thank you.